This dataset was generated entirely in Blender and labeled automatically for object detection. No manual labeling, no scripting, no Python code required, and it's completely free for you to download. Okay, let's talk about what the add-on actually is and what it does. The main purpose of BL Vision is to take in animations and then turn them into annotations. It does nothing really else. It exports right now in both YOLO and COCO formats, which I'll go over next. The YOLO format will always output in this type of structure, where the root folder is the name of your choosing, then subfolders are images and labels, followed by train under each one of those. So I left them as train only because I figured that most people would do their own splitting of their datasets afterwards. And it also generates a data.yaml file based off of the classes that you chose inside the add-on. For the COCO format, there's also the same root folder, name of your choosing. The only difference is that it generates a JSON file with all the annotations inside of it, inside of a folder called annotations, which I think is the normal standard, but that could be changed too if I find out that's going to be not true. Now, the code is available both on GitHub and on my website. You can see those in the description below. But if you go from my website, you can get a toolkit that comes along with the code. That'll include a visualizer, which is a Python GUI that allows you to see the annotations that you actually took, and also some example scenes to get you started. Up next, we'll talk about installation. So first you need to download the zip file, and then go to Preferences, Add-ons, and then go Install from Disk at the top right-hand corner. Locate your zip file wherever you stored it, and then you select it and hit go. So that should install everything. I'm not going to do it myself since I've already done it. But after that, just make sure the check mark is checked and you should be ready to go. You can uncheck that mark and it'll still stay installed. But if you don't want to run it every time, you can uncheck it whenever you'd like. I also have a auto updater, courtesy of CG Cookie. But yeah, you can click on auto check for updates, which may or may not work depending. I still need some testing, it's still under development. But yeah, you can come here and check for updates as things come along. To access the actual sidebar after installation, you can go to that little arrow in the upper right hand corner, or you can try pressing N. Just make sure your mouse is inside the viewport. And it's under BL Vision. And under here, you'll see all the different options that are part of the actual add-on. Okay, so let's get through some of the basic usage of BL Vision, the add-on. So again, to get into the menu, press N or go to this upper right-hand corner to see the tab list. I think this is called the N panel, which reminds you to press N, I guess. So the idea, though, is that the workflow goes from top down. You'll select a mode. You can either select objects individually, which you'll see here, a bunch of benchies, which are these little 3D printed, I guess originally 3D printed design used for testing 3D printers and to see if they are up to what their capabilities are, or troubleshooting 3D prints. But you can see I have a bunch of them listed here. You can also see them in the tree here. There's a lot of these listed, just 41 total listed. So you can either track them individually, or you can do a collection, which I like to do if you have a lot of objects, and they're all the same, and you want to label them the same. So as a collection, they'll all be labeled as Benchy. And I've also put some donuts here. And the reason why I chose these specific pieces is that they provide some challenging aspects for vision, especially for the ray casting feature, which I'll get into later, which is right here. I guess I might as well get into it now, but the ray casting part is essentially a means of sending a beam from some location, in our case it'll be the camera, to see if it hits the mesh, or if it hits the object itself. So this is a good way to test to see if objects are blocked or behind things. So one challenging aspect of that is that a donut has a hole in it. So if you shoot at the center of it, it may not be actually blocked, but the software might think that it's actually blocked. So I've got some other methods here you can probably choose from. I've done a projected mesh, which I think needs a little bit of work. Hopefully more updates will be coming up to improve this, but the idea is that you look at the bounding box of this object, which if you go into the bottom right hand side over here, you should be able to actually visualize that. So you go to object, go to bounds, let's see which one it picked. Didn't pick any of them, so let's go with this guy. Box. So it'll shoot a ray at this box, but then it will project the mesh that is viewable by the camera onto this box, so that you can then say, hey, how many times did this ray hit each part of the mesh? And then you can set a threshold saying, hey, maybe it's 30% or maybe 100%. I think there's a little bit of bugs here. Usually doesn't work anything beyond 50%, so which makes me think that it's taking all the mesh and not just part of the mesh that's viewable by the camera. For example, the backside, and this is the camera, may not see. We don't care about this backside of the mesh itself. So ideally, we'd only take account for the mesh that is facing the camera. Hope to have that fixed soon. So just watch out for that. You can use the automatic updater, so you don't have to go to GitHub every time or my website to download a new version. So it'll be hopefully something that'll come out soon. Yeah, so yeah, you can go to objects, collection, or a particle emitter, which I'll get a little bit to later. If you're not familiar with Blender's particle system, it's actually pretty neat. We'll get into that later, but it's a good way to generate a lot of items like this in a very lightweight way, and it allows you to do a lot of randomization, which I really like. I think it'll be very useful for object detection. So up here again, as you're selecting items, so say we're going for collections, there's a couple options here. You want to be able to set your categories, which are very important for labeling. You can set them manually, either by clicking on here to give you an exact number that you want. Say if I want benchies to be listed as number 1 category, you can name them however you want. You can also do an auto assign if you have a lot of pieces, which I did with the object mode, which there's a lot of these guys here, so I don't want to label them manually. So you can go ahead and say auto assign categories, which will just do a numerical, order of these things. So yeah, that's one way to do that. And then another option here is used instance. So used instances is something that, if you're not familiar with Blender, can be something very powerful. It's a lightweight way of generating a lot of objects without having to store all the mesh. So you're able to do arrays or populate things onto surfaces or randomize things. And then that comes very useful in that type of situation. I might go into a different video to talk about that, because there's a lot to go into for instances, but I found it very powerful myself, so that's why I included it. Now, if you want to test everything, so one thing that's a little bit of a downside of this right now is that you can't see the bounding boxes that are generated until you actually run the system. And if you're running renders and you're familiar with Blender, it can take a while. So I like to do a little bit of troubleshooting ahead of time. So if you go down into, say for example, down here into the timeline, I'm going to bring this out, well, if it decides to crash on me. I'm just going to bring it down a little bit. Let's actually run this guy. Okay, there we go. So the camera is actually viewing these parts right now. So if you switch to camera view, these are the parts that are viewable. You can test the bounding boxes to see how many were done, and it seems like it found 17 bounding boxes. And just to roughly see, let's see if there's 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it found 17 of them in the viewing area of the camera, of which none of them are blocked, because as you can see, none of them are actually blocking each other just yet. But if we go a little bit further, you might see a few that are actually blocking each other. Click the button again to test, to get an idea of what bounding boxes you'll see. So 42, and then out of view are 27. So the out of view is a mix between things that are actually out of view of the camera, but also things that are blocked. So it might have to change that up a little bit to make it more clear to you. I'll consider that in the future. Okay, so now we've gone through basically the workflow here. Collection, we selected collection, selected our objects, gave them a label, chose a raycast method, which we decided to use the projected mesh. There's another one called bounding box origin, which is very simple. Basically just shoots one ray into the center of an object. For this situation, it's not great because there's a hole in the middle of the object, so it's not really the best way to determine if it's being blocked or not. So we're pretty much done with this part of the workflow. So the next part is to actually look at the data output, which is, again, the main purpose of this is to generate annotations. So YOLO or COCO formats, just choose one. YOLO is pretty popular nowadays, I think. So I generally tend to default to this one. It's also easier to read and see if things are going wrong. Make sure this bounding box checkbox is clicked. You may want to re-click this every time you come into a new file or a new scene. There's a little bit of a bug there that will be fixed, but generally do that. And one way to double check to make sure everything is good is to go into your render output and make sure that it matches what you decided to put here. Yeah, so great, perfect. These are aligned. You can specify a prefix for your file, which you can also see here. You can also do some custom paths. I personally don't really use this that often. I put it there just because I think people might want to do that. It gives a little more flexibility, I guess. But yeah, let me know as you go along. You can contact me on GitHub in case you find something that's a little bit easier than what is subjected here. I'm open to suggestions for sure. I would recommend this. Just double check that all the files are pointing to the right locations. And now you're ready to go. So what you can do is you can either run the whole simulation or run the whole animation by going to render animation, which will run the whole animation and then populate your folders with the annotations. Sometimes what I like to do is render one image at a time. It will still generate the labels for that one image. It will overwrite things, but just it's a good way to troubleshoot. I like to do the beginning, middle, and end just to double check that things are working well before I run the animation, because then they can take a while, and it's nice to know that things are going to run fine. So yeah, I mean, now you just hit go and then wait for it to finish. Now for the data output, here is an example that came out of this animation. We have a data.yaml. Let's open that with text edit so you can take a look at it. It did in fact give us a YAML file with the proper names. Gave us a location of the train. I just put the validation one there, even though it does not exist yet. I assume that most people are going to be doing that. And also a path to where everything is stored. In the train folder, you'll see there's no labels there because there's nothing in the first couple of images. So let's see. Oh, there you go. There goes our bounding boxes. The two different categories, 1 and 2. And just to double check, you can see some of the images as well. Let's open up one image with something in it. Okay, great. That's our generated image. So this should be good enough to upload onto either RoboFlow or just to use the Ultralytics workflow and then use that for training. Yeah, I think it's a good start, hopefully. Hopefully if you find this useful and something that you can use in your workflow. If you want to see more, I plan on doing some future videos on some challenging aspects of vision and even some, like, I would say, common scenarios that most people would maybe use in industry. For example, I came from the manufacturing industry, so a lot of our stuff involves robotics, and picking and placing and just seeing things in an environment that we know is gonna what it's gonna be like. But sometimes we don't have the parts available, so it's nice to get the vision training done a little bit earlier, before all of our parts have arrived. And plus, I also don't want to take a bunch of pictures, so it's nice to be able to do a lot of the training digitally and have a Blender generate a lot of the images for me. But yeah, I'll walk through some example scenes for that in the future. So if you want, please subscribe, and then I'll see you next time.